Find the ratio, length AOP to length AOC. Label D and E. Let O be the center point of the circle. Join line OD. It implies that line OA equals line OD, which equals to R, the radius of the semicircle. Consider a square EOCD. Use Pythagoras theorem. The square of line OD equals the square of R, which equals the sum of the square of line OC and the square of line CD. Since area of the square EOCD equals the square of line CD, which equals to 4, it follows that line CD equals the square root of 4, which equals 2 centimeters. The result is equals to line OC. Hence, the square of line OD equals the sum of the square of 2 and the square of 2, which equals 8. Take the square root of the equation. Also, join line OP, which equals to R, from triangle EOA. Use Pythagoras theorem. The square of line AE equals the sum of the square of line OE and the square of line OA. Substitute values and we have that the square of line AE equals the sum of the square of 2 and the square of 2 times the square root of 2, which equals to 12. Take the square root of the equation. It follows that the length of line A equals the square root of 12, which equals 2 times the square root of 3. By trigonometric identity, cosine A equals line OA divided by line AE, which equals to 2 times the square root of 2, all divided by 2 times the square root of 3. The result is equals to the square root of 2 divided by 3. This implies that cosine A equals the square root of 2 divided by 3. We call it equation 1. From isosceles triangle AOP, cosine 180 degrees minus 2 times A equals negative cosine 2 times A, which equals to 1 minus 2 times the square of cosine A. Substitute value of equation 1 and simplify. We have that cosine 180 degrees minus 2 times A equals negative 1 divided by 3. We call it equation 2. Use cosine rule in triangle AOP. The square of line AP equals 2 times the product of the square of R and 1 minus cosine 180 degrees minus 2 times A, which equals 64 divided by 3. After simplification of substituted value. Take the square root of the equation. It implies that line AP equals the square root of 64 divided by 3, which equals 8 divided by the square root of 3. The final result equals 8 times the square root of 3, all divided by 3 in centimeters. But line AOC equals the sum of line OA and line OC, which equals the sum of 2 times the square root of 2 and 2 in centimeters. Therefore, the value of the required ratio, length AOP to the length AC, equals 1/3 of the product of 4 and the square root of 3 times the square root of 2 minus 1. Find the green area. Also, what is the angle alpha? Label point B, O, C, G, D, and E. Let r and small r be the radius of the quarter circle and circle, respectively. It implies that line OB equals to line OD, which equals to r. Line OG equals to line OD minus line DE, that is, equals to r minus small r. But small r equals to the square root of 2. This follows that line OG equals to r minus the square root of 2. Also, line OE equals to line OG minus line EG equals to r minus the square root of 2 minus the square root of 2. Since line EG equals small r equals to the square root of 2, consider triangle GOC. By trigonometric identity, line CG divided by line OG equals to square root of 2 divided by r minus the square root of 2. Sine alpha equals to the square root of 2 divided by r minus the square root of 2. We call it equation 1. From triangle BOE. OE divided by OB equals to r minus 2 times the square root of 2. All divided by r, which equals to sine alpha. Since OB equals to r, it implies that sine alpha equals to r minus 2 times the square root of 2. All divided by r. We call it equation 2. Equate equation 1 and equation 2. We obtained a new equation as shown. Cross multiply. Expand bracket. The square root of 2 times r equals the square of r minus 3 times the product of r and the square root of 2 plus 4. After simplification, combine like terms and use general quadratic equation formula to find r. R equals to 4 times the square root of 2 plus or minus the square root of the square of 4 times the square root of 2 minus 4 times 4. All divided by 2 times 1. Simplify and we have that r equals to the value shown on the screen. It implies that r equals the product of 2 and the square root of 2 minus 1 or the product of 2 and the square root of 2 plus 1. Since r greater than small r, which is equals the square root of 2, r is not equals to the product of 2 and the square root of 2 minus 1. Therefore, r equals to the product of 2 and the sum of the square root of 2 and 1 in units. But line OE equals to r minus 2 times the square root of 2. Substitute value. Line OE equals to 2 after substitution and simplification of values. It implies that consider triangle BOE. Use Pythagoras theorem. The square of line BE equals the square of line OB minus the square of line OE equals the square of r minus 2, which equals to the sum of 8 and 8 times the square root of 2. Take the square root of the equation. Line BE equals to the product of 2 and the square root of the sum of 2 and the product of 2 and the square root of 2. Hence, the green area equals to the area of triangle BOE. which equals to half the product of line OE and line BE. The final result equals the product of 2 and the square root of the sum of 2 and the 2 times the square root of 2. In square units. After simplification of values. Therefore, the green area equals the product 2 and the square root of the sum of 2 and the 2 times the square root of 2. In square units. Solution to question 2. By trigonometric identity. Line OE divided by line OB equals to sine alpha. It implies that sine alpha equals 1 divided by the sum of the square root of 2 and 1. Take the sine inverse of the equation. Therefore, alpha equals the sine inverse of 1 divided by the sum of the square root of 2 and 1, which equals to 24.5 degrees in 1 decimal place. What is the value of the green area? Label points C, G, and K. Locate the center O and letter B the radius of the semicircle. Line B, C equals A, which equals to 4 centimeters. It is because the opposite side lengths of a rectangle are equal. This implies that all these lines are each equals to R, which equals to 4 centimeters. Join line B, D. Line G, C equals 2 times A, which equals to 8 centimeters. The result equals to 2 times R. Consider triangle ABC. Let angle BAC equals to beta. Line BC divided by line AB equals to tan beta, which equals to half. We call it equation 1. By trigonometric identity. The sum of 1 and the square of tan beta equals to the square of the reciprocal of cosine beta. Substitute value from equation 1. The sum of 1 and the square of half equals the square of the reciprocal of cosine beta. Cross multiply and solve for the square of cosine beta. The square of cosine beta equals to 4 divided by 5. Take the square root of the equation. It implies that cosine beta equals to 2 divided by the square root of 5. We call it equation 2. It follows that line AD divided by line A, B equals to cosine beta. Substitute equation 2 and we have that line AD divided by 8 equals 2 divided by square root of 5. This implies that line AD equals to 16 divided by the square root of 5. We call it equation 3. Since line PD is parallel to line AB, draw a perpendicular line from point D to point K. Angle D equals 90 degrees. Hence, angle ADP equals beta, which equals to angle DAB. This is because alternate angles are equal. Consider triangle ADK. Line DK divided by line AD equals to sine beta. Substitute equation 3 for line AD. It follows that line DK divided by the ratio of 16 is to square root of 5 equals sine beta. We call it equation T. By trigonometric identity, sine beta equals the square root of 1 minus the square of cosine beta. Substitute value of equation 2. It signify that sine beta equals 1 divided by the square root of 5. After substitution and simplification of value, we call it equation 4. Line dk divided by line AD equals to sine beta. Substitute equation 3 and equation 4. Line dk divided by the ratio of 16 to square root of 5 equals 1 divided by the square root of 5. Cross multiply and we have that line dk equals to 16 divided by 5 in centimeters. After simplification of substituted values, label point F and join line FP. Also, join line OP and line OD. Each equals to R, which equals to 4 centimeters. Since line DK equals line FP, it is because opposite side lengths of a rectangle are equal. Use Pythagoras theorem. The square of line OK equals the square of line OD minus the square of line DK. Substitute values. The square of line OK equals the square of 4 minus the square of 16 divided by 5, which equals 144 divided by 25. Take the square root of the equation. It implies that line OK equals the square root of 144 divided by 25, which equals 12 divided by 5. The result equals line OF. Triangle PFO equals to triangle DKO. It is because congruent triangles are equal. This implies that line KOF equals 2 times line OK, which equals 24 divided by 5. But line KOF equals line DP, which equals 24 divided by 5. We call it equation 6. This is because opposite side lengths of a rectangle are equal. It follows that area of triangle PDA equals half the product of line DP and line AOD times sine beta. Substitute values from equation 3, equation 4 and equation 5. It implies that area of triangle PDA equals 24 divided by 5 times the product of 16 divided by the square root of 5 and 1 divided by the square root of 5 times half, which equals 192 divided by 25 in square centimeters. But area of triangle PDA equals the green area. Therefore, the green area equals 192 divided by 25 square centimeters. What is the green area? Label B, C, D, E, G, F, and H. Let O be the center point of the green large semicircle. Also, let A be the radius of the pink semicircle. Its area equals half the product of pi and the square of r, which equals 7 square units. Make the square of r the subject of the formula. We have that the square of r equals 14 divided by pi. Take the square root of the equation. r equals the square root of 14 divided by pi. Its diameter is 2 times r, which equals to 2 times 14 divided by pi. The result equals to line CF. Join line BF. Let the length of the smaller square be x and that of the larger square be y. It implies that line G equals line D, F which equals to line B, C, the result equals to x, and line B or F equals line C, D which equals to y. From triangle BCF. Using Pythagoras theorem. The square of line BF equals the square of line CF minus the square of line BC, which equals the square of 2 times the square root of 14 divided by pi minus the square of x. Simplify and we have that the square of y equals 56 divided by pi minus the square of x. Make the square of x the subject of the formula. We obtained an equation for the square of x as shown on the screen. Take the square root of the equation. We have that x equals the square root of 56 divided by pi minus the square of y. We call it equation 1. Line BH equals y minus x, which equals y minus the square root of 56 divided by pi minus the square of y. Hence, line FG equals line DE, which equals to x. The result is equals to the square root of 56 divided by pi minus the square of y. Consider triangle HBG. Line BG equals the result shown on the screen. By Pythagoras theorem, the square of line HG equals the square of line BH and the square of line BG, which equals 112 divided by pi. After simplification of substituted values. Take the square root of the equation. Line HG equals the square root of 112 divided by pi. Let r be the radius of the green semicircle. It implies that line HG equals 2 times r, which equals the square root of 112 divided by pi. Hence, r equals half the square root of 112 divided by pi, which equals to 2 times the square root of 7 divided by pi. The result equals line OH. The green area equals half the product of pi and the square root of r, which equals 14 square units. After simplification of substituted values. Therefore, the green area equals 14 square units.